the School of Physics. Today we are going to revise everything that is needed for any objective exam for the topic kinematics. So kinematics is a very important topic and we are going to do it today. Let's begin. So I have this point x1 and I have this point x2. The distance between these 2 points is x2 minus x1, which we can also say which is equal to the distance covered. I have velocity v1 at the initial position. I have velocity v2 at the final position. So we can say v2 minus v1 is equal to delta v, change in velocity. Similarly, we can write this as delta x. This is time t1, this is time t2. So t2 minus t1 is equal to delta t. We can write acceleration is equal to, acceleration A is equal to change in velocity, final velocity minus initial velocity. We also represent, say, final velocity by v and initial velocity by the letter u upon time t2 minus t1, which we can write as v minus u upon t is the acceleration. Now velocity average can be written as x2 minus x1 upon t2 minus t1, which can be written as s upon t. Right. Now whenever we have constant acceleration, we have 3 equations of motion. In case of a constant acceleration, we have 3 equations of motion which we follow as equation number 1, it is v final velocity is equal to initial velocity plus acceleration into time. The second equation of motion can be written as s, which is the distance, is equal to ut plus half at square, The third equation of motion is v square minus u square, final velocity square minus initial velocity square, is equal to 2 times of acceleration into the displacement. S is the displacement. And in case of relative velocity, so suppose there is this particle A going with a velocity VA and there is this another particle B which is going with this velocity VB. So relative velocity of B with respect to A, V relative velocity of B with respect to A is equal to velocity vector VB minus velocity vector VA. Now, these were the things that we required for kinematics, and next topic that we come to is projectile motion. So we begin projectile motion. Projectile motion is a very important topic, and since we are doing this for objective exams, all that we need to do is learn the direct formulas. And one question from projectile motion is guaranteed to be there in the paper because projectile motion is very important. So next is projectile motion. Now what is projectile motion? We have a particle going with velocity u at an angle theta from the ground. Then the velocity in the x direction is u cos theta. Here we have this frame of reference. This is x and this is y direction. Now velocity in the x direction is u cos theta and the velocity in the y direction will be u sin theta. How do these equations come? How do these results come? They come from the equation of motion that we wrote, the 3 equations of motion. But since we are doing this for the objective exam, we'll just learn the results and apply them directly. That is the smart work. Apply them directly in the exam. So what happens is, this is how the projectile motion goes. If the total time taken for this motion to happen is time t, and this distance is called range r, and this is the maximum height that the projectile motion achieves. So time will be written as 2u sine theta upon g. Time will be written as 2u sine theta upon g. Now I am going to teach you a trick on how to remember the results for the range r and for the maximum height h. So for range r, what we'll do is we'll put this 2 here and we'll also put this 2 here. Okay, so the result becomes u square sine 2 theta upon g is the formula for range r. We put this 2 here, which makes it u square, and we put this 2 also here, which makes it sine 2 theta. So the formula for range is u square sine 2 theta upon g. For the result of height, what we do is we take this 2 upwards here and we take this 2 downwards. For the result of height h, what we do is we take this 2 upwards and we take this 2 downwards. So the result for height h becomes u square sine square theta upon 2g. U square sine square theta upon 2g. Now we are doing this next thing, in which if at any time t, what is the distance at any time t, what is the distance that is covered in the x direction. So at any time t, the distance covered in the x direction can be u cos theta into t, that is velocity in the x direction into time t. And what will be the distance covered in the y direction at any time t? It will be written as u sine theta into t minus half gt square. Where do these results come from? These results are derived from the 3 equations of motion. Now the next formula is the very important one, and most of the people waste their time in the main exam by doing it normally, like from the basic equations of motion, when a very direct question will appear in the exam based on this formula, which is the relation between y and x. So y can be written as x tan theta, you have to remember this, y can be written as x tan theta minus x square into g upon 2 u square cos square theta upon 2 u square cos square theta. Very important formula. All you have to do is remember all these formulas in projectile motion and apply them directly in the exam. So this was my lecture on kinematics and projectile motion. I hope you enjoyed it. Please subscribe the channel for more videos. Thank you.